attendees are in listen-only mode.
Hi, this is Paul Price with Iasa. I wanted to thank you all for joining us today. As a treat, we've got Scott Anderson talk today from Lockheed Martin. Hi, Scott.
Hi.
Scott will be talking about cloud computing, and I'm just going to take a brief moment of your time to talk a little bit about Iasa programs and the things that we offer organizations and individual architects. Wanted to again remind you that we do these presentations for members and for organizations, etc., on a regular basis, where we offer different programs to increase learning and knowledge development as well as skills development for practicing architects. And Isa's, so we're just going to run through a couple of quick slides here about that, and then we'll turn things over to Scott and get going on the cloud computing. There we go. Sorry about that. And so as I was saying, Iasa offers a set of programs for organizations such as the ASAP program, which provides organizational dynamic or organizational integration with a vendor model that ensures the skills and capabilities of the services firms that you're working with. And what that does is it normalizes the relationship between architects and at the vendor level and architects at the customer level to help augment the development of or augment the success of projects done at the with your vendor community or with your customers if you're a vendor. And the nature of that program is to ensure that there is a level of credential in all RFPs and in job descriptions going forward that would specify the capability that an architect has reached. So if, for example, you're experiencing issues in your success with vendor organizations in your current project list, you may want to consider something like ASAP to help increase the level leveled requirements from your vendor community to ensure that they're providing you the right staffing models. As well, we also have a corporate consortium at Iasa that allows us to standardize on those skills and the capabilities of the practicing architect. And this ongoing working group at Iasa includes many of the larger organizations in the world and their representatives to ensure that the capabilities that are in the Iasa models are normalized and represent best practice. So on those roles and job descriptions that we certify and look at, Iasa identifies five primary roles, and those are enterprise, business, information, infrastructure, and software architecture. These are roles that we have available job descriptions for, as well as roles that we certify against both at the knowledge level in our Iasa foundation and core foundation certification and associate certifications, as well as at the experience level in our CITA-P or Certified IT Architect Professional certification, which is a board interview, a panel interview based certification where you demonstrate the experience that you've gathered in putting these skills into practice. We also do development of team assessments where we build assessments of your architecture teams and set goals for those teams in terms of value provided back to the organization in these 6-month, 12-month, 18-month, and 24-month timeframes. So it's a very agile team assessment where we look at the development of team goals and individual practice goals to ensure that that you're able to communicate the value you're generating on a regular basis. We have the ISA Curriculum Education program, which provides education at the core level to standardize the skill set and architect language at your organization, baseline your employee skills. So we have non-architects, in fact, going through ISA Core on a regular basis, just so that language and core relationship between architecture and its constituents is clarified. That also walks through a full architect life cycle so that you can actually practice those skills and develop them. The ISA Associate goes in much more in depth in the human dynamics, business technology strategy, and software information infrastructure and business architecture. And then finally, the CITA professional preparation courses to allow the senior-most architects to help prepare for their board-level certification. I also want to mention the ISA mentoring program, where you can connect with the top architects in the world. In fact, Scott Anderson, our speaker today, is a mentor in that program. So if you like what you hear and you have questions, you might want to check out that program. That is a 12-month program that allows you access to a number of mentors on an ongoing fashion. So the latest offering from the ISA is the ISA engagement model. We have successfully worked with best practices from organizations around the world, and one of the things that we're offering is to work with your teams on how they engage your business to ensure that you're getting full coverage. And basically it works to set the goals of the team, as we discussed earlier, and then align the decisions and components of your architectural engagement, meaning how you touch your internal customers or external customers, in such a way that you optimize according to best practice the value generated, and that the overall architecture touch points in the organization are being successful. So these kind of activities will and engagement are ultimately where architecture teams fail, according to our statistics, in not guiding their practice in the most effective manner and making decisions prior to runtime and not reacting, but proactively deciding on the value that they're going to generate. So the engagement model includes touch points throughout the enterprise, and what that means is really how do your architects touch the entire enterprise. Now, we've drawn a basic model here of the enterprise with lines of business and with business capabilities in place, and this is a estimated distribution of and touch points where our architects spend most of their time. It's not necessarily a reporting structure. So we can talk about the engagement maturity model and engagement assessment as we move forward. But for the time being, I want to let you get to Scott. And Scott, are you prepared to share your slides?
I sure am.
All right, we're just gonna do that, and we should be ready to go. Just share your screen whenever you're ready. For those of you who have questions, while Scott brings up his slides, I want to point out that there is a question and answer panel. You can type those questions in. I imagine your first question is, what's going to happen to this presentation? It is being recorded, and we will be posting that on our YouTube channel as well as on the ISA content repository at www.isaglobal.org. So, Scott, I'm going to turn it over to you. And thank you very much.
Thanks, Paul. So first of all, welcome one and all. My name is Scott Anderson. I am actually the chairman of ISA's Board of Education, which is a source of great pride for me. It's the organization that helps put out some of the stuff that Paul just showed you. So a very good opportunity to get involved with ISA, but also just a really great way to get back to the broader community. Today we're going to talk a little bit about cloud computing, and in particular we're going to talk about one group's view of what cloud computing is, and that group is the NIST, or the National Institute of Standards. That is a U.S. body that focuses on building out what the government should be doing, the U.S. government, go forward. Of note, however, is the fact that in the reference architectures published for cloud computing, NIST is actually reaching out to other organizations, countries, and groups to say, we would like to adopt this lovely standard that we've developed. And this, the goal is to make it a universal and international standard. I'm not going to read through all the terms. Everybody's familiar. There's quite a few. And interesting, and if you read any of the NIST documentations at this point and listen to any of the NIST speakers, I think the most interesting thing I've heard from NIST in the past 6 months is a huge push from them to get everybody to stop adding as a service to whatever it is they're offering. So I was going to call this Cloud as a Service presentation, but in respect for what NIST has asked us to do, I'm not going to call this an as a service presentation. So we're going to talk through some of the effective uses, some of the models, resources, and security for cloud computing from a NIST perspective. So first of all, effective and secure use. Very excellent picture on the screen of a motorcycle rider who has leaped into the air. I would not personally use a motorcycle that way, but that particular person is trained and is effective and good at what they do and is able to leverage that tool. So we're going to talk about understanding what cloud computing is. First off, it is truly clay right now. It is a lot of things, but it is not baked yet. We don't even have a color completely yet for cloud computing. We don't have necessarily a formed shape, and we don't necessarily have a final shape. What we do have is an idea of what cloud computing might be, and a realization that there are a number of things that will have to happen for cloud computing to be effective in the next 3 to 5 years. Over the next, say, 18 to 24 months, the thing you're going to see in cloud computing, and the reason that CIOs are going to look at cloud computing is cost reduction. In the U.S. government, there's a mandate from Vivek Kundra originally, and now Stephen Van Urkel, to leverage the cloud first, to look at the cloud and make sure that whatever solution you're building can't be cloud-enabled today. The reason for that is cost cutting. And for those of you not familiar, right now the U.S. federal government has undergone or is undergoing a significant budgetary change, and that change is going to result in a significant drop in the federal IT budget. Analysts are saying anywhere from $25 billion to $30 billion less IT spend by the U.S. federal government over the next 2 to 3 years. So a significant amount of money, not chump change, a lot of money. And because of that, cloud computing is an initial push for organizations. And there are some cost savings and some benefits in a short-run scenario if you're very careful with what you do. For a larger organization, cloud, not necessarily the best answer for a lot of solutions. But in a small or more agile format, it is a very quick way to save money. Unfortunately, all of us, being IT professionals, know what happens when you save money. Money saved by IT doesn't miraculously come back to the IT budget. It disappears forever. So this is a cost-cutting measure. That's certainly a value proposition of cloud computing in the near term. There are other things to think about. So, Kevin Marks, one of the originators of the internet, one of the first guys to really go back years ago and start building on the original DARPANET programs, talks about the fact that, in the old days we drew the network as a cloud. Everything was hidden from us because it was a cloud, and that's why we kind of go really build on the concept of cloud. The interesting reality that we have now is that cloud computing can mean anything from a private run data center to truly a full community cloud implementation of a messaging system shared by 40, 50, or 60 companies with a common or interesting interest in a solution. Cloud computing is basically a model, this is the NIST definition, for creating pools of computing resources that involve network, storage, and capacity with the concept of elasticity. And we'll talk a little bit about elasticity because that is the one thing that will change how cloud is impacting the world around us over the next few years. And the add-in, that NIST doesn't currently have, but has just spun up a working group. So NIST has just brought up a working group for the concept of mobility. The question of mobility is really ultimately, if you think about your mobile phone, 99.99999% of what you use your mobile phone for, other than GPS, is a cloud app. And in many cases, you even use a cloud version of a GPS app. So the mobile device in and of itself is truly almost a cloud platform. So as you think about it, what is the tool? It is the tool for cloud. So NIST is beginning to look at that. The 5 characteristics, and again, this is NIST's model. It's a very good model, but it doesn't allow for a lot of variance today. I think there are things that are yet to come, but the big ones are on-demand self-service, so broad network access, the concept of resource pooling. I'm independent from location. I don't have to be a specific place. Rapid elasticity and measured service. Now, of these 5, what we can argue, and I think it is a fair argument, 3 of the 5 actually were things that IT probably would have done on their own without cloud over the last 5 years, but because of budget cuts and other concerns, IT has not spent that money building these new programs, and in particular the measured service, resource pooling, and on-demand self-service components. So while those are linked to cloud today, we could argue that those are simply things that IT hasn't had a chance to actually do, and simply adding those components as an initial cloud resource. There are 3 models, and you'll notice I said in the beginning of the call that NIST does not like adding as a service, so there is no services, and I'll talk a couple of them, but for the most part you have SaaS, which is software as a service, PaaS, which is that platform as a service, and then the last is IaaS or IaaS, which is the infrastructure as a service. Now, the infrastructure as a service component can be broken into 2 pieces, and that's the hardware and the software required to build and deploy a solution. For example, the server OS that the virtual machines sit on, the server OS that the server sits on, all of those components are part of an infrastructure service, and that would include all the management and operational tools required and security tools required to manifest that solution. PaaS and SaaS build on IaaS, and you'll see, depending upon who you base your presentation on, you'll see a number of variants of this. Many people put IaaS, PaaS, and then SaaS. Some people, however, point out that a future state PaaS solution would actually pull from both the SaaS layer and the IaaS layer, and so they put PaaS on top. So it's an interesting world. There are a number of other options out there that have been bandied about. One is data as a service. That would be in the IaaS layer, but it would be a storage or structural component that stored and allowed for the manipulation of the data by the other 2 layers. There's an information as a service. I've seen the concept of business process as a service, BPAAS. Information is INAAS, and a number of others. But based on the NIST definition, we really want to consider these 3 as the baseline, because you can argue that virtually any solution we deploy fits into one of these 3 buckets. So when we think about this then in terms of what's out there, and again, this is the stack that I just talked through, you begin to see that in many cases we can build a very structured and logical view of what we're deploying. There are 4 models of clouds. The 4 models are private, community, public, and hybrid. Now, NIST, being a government agency, calls public sold to the public and a mega-scale infrastructure. In many cases, the U.S. government is actually going to a public cloud scenario as well, as many other governments are. And the concept of community cloud really resonates well pretty much across the board, where you have groups of people, groups of organization, groups of companies that are like-minded and have similar concepts and requirements for a solution. A community cloud is a very good fit because over time what you can do is leverage the common infrastructure. Going back to that software rule from the dawn of our IT past, the 80-20 rule. The community cloud really talks to the 80-20 rule. The private cloud can actually be managed by your vendor off-site or can be physically managed on-site. And it really is just an application of the 5 core principles we talked about earlier within the IT infrastructure that exists today. And the last one is then, of course, hybrid cloud. And the interesting argument that you'll have with most people is, truly what is a hybrid cloud? And there's 2 flavors of hybrid clouds out there in terms of what people believe. One is that it's a meshing or combination of 2 or more clouds. The other is that it's the meshing of a cloud solution, community, or public, or private, and your on-premise solution. Because there are some things that have to occur during a transition to cloud that will require some hybrid technologies that are uniquely not available today. Common characteristics, everybody's aware of this, heavily based on what was the SOA world of a few years ago, everything as a service, trying to build out the service solutions, advanced security, resilient computing. So that's the concept of multiple data centers running multiple sets of your data so that if any one goes down, you're never going to be offline, because the reality is you have that high availability and DR built in, massive scale, and then the concept of virtualization. Contrary to a vendor I won't name out loud, virtualization is not cloud computing. Virtualization is a piece, but it is not cloud computing. The NIST framework laid out, as you can see, you'll notice that they have hybrid cloud over the top because it is truly a blending, and then underneath that, the component pieces. The one thing to note, and you're going to see a lot of this as things go forward, is this concept of low-cost software. One of the things that you'll really see a value proposition in the cloud, particularly with the self-provisioning, is the ability to take applications that you've, as an IT shop, deployed for years to the desktop and now say, you know what, we're going to allow people, we're going to buy 1,000 copies of Visio instead of the 20,000 we buy today, and we're going to allow people to rent them. And what you do is you basically pay for the cost as IT with chargeback, or you don't even have to do that. You can just absorb the cost as an organization of the software, but you also reduce the number of licenses because not everybody needs every application every minute of every day. If you're in Word, you may not use Excel, PowerPoint, or anything else all day that day. So reducing the cost and lowering the cost of your software that way, as well as looking at the myriad of open source solutions that are out there that allow you to get to where you want to be without spending a licensing fee on a yearly basis. So security. Security is a huge issue. This is done from an IDC panel in 2008. It's less today than it was in 2008, but it's still pretty hefty. The reality is the biggest problem for most organizations, in particular rating it as a 5 or very significant, 75% of people said that security, and 63% were concerned about performance and availability. The last one, you'll notice, or the fourth, is hard to integrate with in-house IT is really the hybrid cloud problem. It is very difficult today to create a way to easily share your directory container outside of your organization. So what's out there? Well, you've got multi-tenancy, you've got trust, you've got encryption, you've got compliance. Clouds are extremely complex systems. They are really, really, really broken into common functional units, and you end state have a problem. You have this concept of cloud, which is an entity of computer functionality, and on top of that you have security. We can trace it, and there are things that we can talk about with cloud computing. There are advantages with cloud computing, and then there are challenges. General security advantages of cloud computing are pretty straightforward. First of all, you have public data. When you shift public data up to external cloud, you're reducing the exposure of information. If your information is all stored, public and private, in one container, your increase of risk is significant because there's information you share publicly and there's information you don't want shared publicly. So you decrease that risk by separating the 2 data stores. The nature of the cloud, and because the cloud is homogeneous across, you're able to do better auditing and better controls across your clouds. You have automated security management, things that you can do. I work for a global security company right now, and one of the things that we're about to bring out is a database structure and system to help with some of these attacks and playing offense, not playing defense and security. And then finally, you do have significant redundancy and disaster recovery, so you're not as exposed to any one data center or store going down. The value proposition there is that that significantly reduces a denial of service attack impact, because if you take out one data center, it only takes out one; it doesn't take out both. And it's a fairly massive effort to mount two simultaneous denial of service attacks. And the reality is, if you do a community or other type cloud, you're going to actually end up attacking a bunch of organizations that may not be the ones that you're going after. So some significant advantages. There are, however, some challenges. The first is the model of the vendor's security, what they offer you. Pretty significant variances there. There are probably 8, maybe 10 companies that offer what would be a true security model across the entire organization. All of them consider themselves threat-based modeling and those types of components. There's a number of types of models out there, from Microsoft's SDL to some of the other solutions that are available. The reality of the data is that because you're going to get more security data, you're going to be limited by that data. The more data you get, if you don't know how to process it and act on it, the relevance of the data goes away. It's simply too hard to know what to react to if you're not trained in the process. Finding a partner to help you with investigations. There are a number of security concerns that cloud computing, as well as computing in general, bring up. The first thing is you have to determine what type of security risk does your organization have. Are you an external-based organization? For example, a power company is more concerned about external attacks than they are internal attacks. But a bank is more worried about internal attacks than external attacks. They're very much concerned with external attacks, but they're very worried about that internal person being corrupted and allowing for the change. You have the problem of indirect administrative accountability, not having a way to monitor and manage the administrators. You cannot look sometimes at proprietary implementations because nobody built the metrics in or the components in. The U.S. government just passed a regulation called FedRAMP. Part of FedRAMP is a number of parameters that must be in every application. For an application in a data center to be FedRAMP certified, you have to have those metrics and components in your solution before the U.S. government will actually allow for that solution to be in the FedRAMP system. And then last but not least, loss of physical control. As a former IT administrator and mail administrator, I do recall there were days, a number of days unfortunately I would suspect, where simply power cycling the server was the only answer that I could come up with at the time. There probably were better answers, but I did have that control. I did have that ability to say, I'm going to recycle this server now. Versus today, in the cloud environment, you lose that. Some relevant components that we need to think about. Cloud provisioning, obviously, how services are provisioned can be a significant exposure point. If you have a system that allows for fairly generic provisioning with a minimum set, compromising an ID could generate thousands of virtual machines fairly quickly. The cost of that, if you're on an Amazon or something, or a Terramark, can be fairly significant. Cloud data is a persistent cost. They always talk about utility computing, but if you use disk today and you store stuff in it for tomorrow, even though you don't use the CPU, you're still going to get charged for the storage, and that persistent storage is out there. Now, the good side of it is that if you're in a community cloud, your data may be on a disk that nobody can find. The bad news is your data is sitting out there in the cloud and somebody can beat on it all day long. The processing infrastructure, the support services, and the network and perimeter security are all critical components within what you're going to do. The other advantage, the cloud providers, as you go forward, are going to be smarter. then IT will be on site. The reason they're going to be smarter, they're going to see a lot more attacks. They're going to see many more attacks, and they're going to get smarter, and they're going to get better at it, and they're going to really, over time, make cloud computing more secure than on-prem IT. So provisioning service, the advantage, you can rapidly reconstitute services. So you can take a solution down and bring it back up very quickly. Allows you to do some honeynet. You can actually build out a fake version of your solution to capture and trap a hacker in a fake solution. Unfortunately, and as I talked, the challenge is somebody compromises your provisioning service. Data. You've got fragmentation and dispersal. You've got data replicated automatically. You've got zones, so you can follow the legal and regulatory rules of the EU, the European Union, versus the Canadian rules, the UK government rules, the rules in various Asian countries, US and South American countries. You can encrypt the data at rest, and you can encrypt it in transit. And then you can also do the concept of automated data retention, where it is automatically stored and maintained. Now, you do have the concept of isolation management and data multi-tenancy. The concept there is tagging the data. How do I tag it, and can I tag my data? And if I tag my data, what can I tag it with? How secure can I make it? Single point of failure with your storage controller, and of course your data in theory can be exposed to foreign governments. Now, obviously that's a US government position, but if you take that and spin it and present this from a UK perspective, they have the same issues as does any other EU country, any Asian country, and frankly any country in North or South America. The reality is you don't want your data exposed to the wrong people, and the wrong people are always everybody except you. Processing infrastructure advantages. You have the ability to create masters and push things out. Push out your images, push out your process very quickly. Challenges, again, we're talking back to the data tagging. Because of the application multi-tenancy, you have the reality of what are you going to do forward with that data tagging. You have reliance on the hypervisors. There's 3 huge players right now and a couple of those open source players that are growing. You've got the Zen solution used by Citrix and others. You've got Hypervisor from Microsoft and VMware from VM. All of those hypervisors are a risk for you as you go forward because, frankly, you're reliant on them. And changes and fixes aren't necessarily going to reflect your particular scenario. And then finally, the ability to isolate your processes and the ability to create application sandboxes. This would be the perfect cloud world, would be the ability to create a test dev/production environment and then a production environment. But if you look at the cost of that, it's fairly significant to create that type of environment. And so there are things you have to look at and consider. Cloud support services. You've got on-demand security, authentication, logging, firewalls. You've got trained professionals. You've got people who see problems, hundreds of problems every day. The best person to call if you're having a problem you can't figure out, and most of us have been in the IT world for a number of years, and the reality of anytime you've been somewhere, you've got a good set of knowledge, but there are times when you just need to call that person on the telephone and just talk to them because they may have seen that 1,000 times. You have additional risk, of course, when you have an integrated customer application, so there's always that. Certification and accreditation of separate application sets, and then updating the code. You could be updating code that impacts a bunch of applications now instead of 1 or 2. Perimeter security and network security. You've got, again, we talked about that concept of less risk for denial of service. You've got the capability around VLANs. You've got perimeter security with the new releases of VMware and the new release of Zen. You actually have the concept of a virtual data center where you can create that virtual data center that is completely firewalled off, which allows for the creation of a secure community cloud. Of course, your challenges, you've got the concept of virtual zoning, but then you've got application mobility. So that conflict will cause you problems. So again, we talked a lot about these. You've got hypervisor protection, keeps you greater resiliency. You've got fault tolerance reliability. You've got the concepts of a dedicated security team. You've got data dispersal, all of which gives you an advantage as you go forward. You've got simplification of compliance analysis. Since you know where everything is in the cloud, it's much easier to pull that compliance analysis back. Like I said, Lockheed is actually about to release a product where we will sell to a customer all of the cert and other components that we pull together on a monthly basis into a single unified view of what the attacks look like, including views from some of the social media sites as well. Your data is held by an unbiased party. That's the cloud's vendor, and they are kind of, as they exist, they're going to be unbiased. The reality, however, of that is the other side. I worked with a customer in Chicago, Illinois for a while who was doing some hosting for a number of customers. The FBI decided to investigate one of the companies, and because of the nature of cloud, unfortunately the FBI came in and pulled all the disks from a server in order to do forensic analysis of those disks. Those disks had, at that time, because it was a single data center implementation of a private cloud, it had all the data on those disks. So there are risks there. You've got some value propositions, real-time detection of the system tampering, IDS systems for everybody in a cloud. You've got the advantages of building advanced honey-nets. You can rapidly reconstitute your services, so if things go down, you could strip them and rebuild them. You do have a number of things that you have to worry about, including the fact that anytime you cross a border in this wonderful world of ours, there are a number of different programs out there. The EU has a very specific set of privacy and security components that are required. The U.S. has the safe harbor and other programs that are required. There is a program in the U.S. called ITAR, which involves what you cannot push across a national border, the national border in that case being the U.S. And of course every country underneath that has a number of other layers of infrastructure and component around this concept of security and security management. There are many cases where you have a need for isolation management. You have the problems of multi-tenancy. And again, we talked about data tagging and some of the other components of multi-tenancy. You've got logging challenges. You've got data ownership issues. If it's U.S. government data, but it's sitting in Germany, who actually owns the data? The way it works today is the U.S. government actually has military bases in Germany, and once you cross the fence into a U.S. military facility, it's actually U.S. soil. It's not German soil. And that's by treaty and organized and controlled by both organizations, so that once you cross into a military base, you are on the sovereign territory of that country. Any data there remains the sovereign data of that country. If it is, however, not in that facility and somewhere else, how do you own it? Who owns it? And then finally, quality of service guarantees. 3 years ago, if you'd asked a cloud vendor for an SLA, you wouldn't have got one. 2 years ago, they'd have laughed at you. A year ago, they'd have said, well, we're thinking about doing them. You're beginning to see service level agreements now, but the service level agreements you're beginning to see are not the ones that you're used to from a traditional IT perspective. Most cloud vendors will go 99.9. Some will go to 99.95, but that's very few. And when they, by the way, go to that 99.95, they will charge you for that pleasure and joy. Excuse me. Again, dependence on security of the virtual OS in the cloud is a critical one. Encryption needs. So basically encrypting the data wherever it is, encrypting the access to it. You've got the concept and the argument of public cloud versus private cloud security. And then really the lack of the public SaaS version control is a last big security thing. So there's some things that we need to think about, PII and sensitive data. We have to be really careful what we move and how we move it. We have to really go out and build out some really good SLAs in the NIST reference architecture documents, which is NIST Special Publication 500- and I think it's 893. There's a bunch of good reference SLAs to use. There's some issues with cloud forensics. It's a lot of data. And one of the things that you have to start thinking about is in order to determine what and who is attacking your cloud solution, you really have to think about, gathering data from the social media. On average, Twitter produces about 10 terabytes of raw data a day. Facebook way more than that. And that's a lot of data to be sorted through and figured out what's relevant, what's important, and ultimately, what do I need? And then you've got to look at handling compliance itself. The U.S. government, as I mentioned, has FedRAMP. There's also FISMA. There's the Health Information Privacy Act, or HIPAA, which allows you to maybe move or not move your information. There's the Sarbanes-Oxley Act, PCI, and SAS-70. Those are all security components and compliance components that apply to cloud solutions. So that's great, well and good, but the goal of the presentation was how do I get to where I want to be? So if you've decided that cloud is your future and you haven't convinced your CIO to take his Harry Potter wand into the data center and bless it as a data center, I suspect you'd probably knight it as a data center at that point, you're going to need to migrate. If you think about the way geese migrate, they move 3,000 to 4,000 miles, and they go to the same place every time. The same geese go to the same place every time. And it's rather an amazing concept. It's how they move, what they're able to do, and how they're able to fly across the country. But moving data the same time, the same place, that's a very big dream. So the first thing, number of benefits. There's cost savings, there's power savings, there's green savings. I've looked at a number of U.S. government, number of commercial companies, and as well as Lockheed Martin internal information. And the amount of money that you can save from power and green savings simply by moving towards the private cloud scenario are significant. Larger companies can save as much as $1 to $2, even $3 million a year, every year, in power and consumption. They can reduce their CO2 footprint significantly year over year by simply moving. But those issues of security will drive and really define how cloud computing will be adapted and adopted in the next few years. So how do we balance the threat with cost effectiveness? A private cloud may have less threat exposure because it's behind multiple firewalls and we can now add additional. A community cloud may have more threat in the sense that it's shared, but it may have more common services, so there's ways to get around that threat of risk. A massive public cloud is going to be the most cost effective because it's simply going to be managed and controlled, and you're also going to have the ability to have many, many, many more solutions. If you think about why does Amazon offer a cloud, one of the interesting arguments would be that Amazon has a cloud today because at one point or another they realized that come November X in the U.S., which is the day after the U.S. holiday Thanksgiving, is a day called Black Friday. Black Friday is the heaviest shopping day for physical shopping stores in the U.S. Following Black Friday, that next Monday is actually called Cyber Monday, and this year was the first year that Cyber Monday was actually larger economically than Black Friday was. Cyber Monday is the day when Amazon's cloud is maxed out. I would bet that the entire Amazon cloud probably ran at close to 90%. Because Amazon sucked up as many free resources as it could to make sure it was able to handle and deliver on the promise of all the orders they had to take at that time period. So it's an intriguing situation. So what are the things out there? So first of all, clouds tend to have a single security architecture, but each customer in that cloud will have different demands, particularly with a public cloud model. So if you think about the big boys in public cloud hosting today, they're all going to have a single security model. That model may not apply directly to you. In fact, it may be best for customers to really seriously consider what it is that they want first in terms of security and build from security out. You're going to be a lot better off if you have a security model that closely adapts and adopts what you want to do rather than trying to model your existing solution to a security model that doesn't fit. You'll have more control over a private cloud than a public cloud in terms of security. Doesn't really, if you're not good at security, it doesn't really matter which way you go at that point. But if you're good with security and you have a model and a process and a plan, a private cloud will offer you more security in the short run. And you're probably looking at highly sensitive data being processed by clouds where the organization has control. If you think about the last 2 years, we've probably had 8 or 9 breaches of fairly major customer databases that included all of the relevant information about that customer. At this point, in order to borrow somebody's identity, you need their date of birth, you need their social security number, you'll need their mother's maiden name, you'll need a few other pieces of relevant information, and if you have that information, you can pretty much spoof their ID, which, good, bad, or indifferent at that particular point, results in a security problem. So the reality is most clouds are going to require very strong security. All the models of the clouds that we have out there as we migrate to them can be used for different threat exposure models and efficiencies. We just need to do the trade-offs across them. There's no one cloud. There are many models and architectures go forward. And the big question, how do you choose? So number one, for those of you familiar with, again, the U.S. government, Vivek Kundra issued the Cloud First mandate about 1.5 years ago. The Cloud First mandate said basically, no matter what, whatever you are doing, you must look at the cloud for the solution. You don't have to deploy to the cloud, but you do have to look at the cloud. When Vivek left to go to Harvard, Stephen Van Urkel took over, and Stephen modified Vivek's original statement slightly in that he said, yes, I want you to look at the cloud first, period, but I also want you to consider future-proofing your solution. Make sure you don't do something stupid just because it's the easy way. Since then, the U.S. Congress has mandated that the Department of Defense don't just look at private clouds, that they actually expand beyond that, and they develop solutions based on the public cloud models. So number one, use public cloud. Public cloud applications are not one-to-one migrations. That's the fatal flaw that a lot of people have made the mistake of jumping down the path of. A cloud application is different than a non-cloud application. In the old days, and I'm as guilty of this as anybody, so this is not a criticism, it's simply a statement of the way things used to be. In the old days, we used to throw hardware at problems. Your Exchange server is chewing up its processor, add another Exchange server. Your web server is chewing up the disk, add more disk to the web server. Throwing hardware at problems created a situation where we had much more hardware than we needed. We designed for the capacity, not for the reality. And the reality of every system, if you look at it, is much less than the capacity. In fact, capacity is at 100 to 105%, although if somebody could explain to me how you could have 105% of capacity. If you know your capacity is 100, it's 100. 105% is 100 then. But if your capacity is 100% and you think about that concept of 100%, that's what you have to buy for if you build your own. Including if you build your own private cloud, you have to buy 100% of your capacity needs. Or in the case of your own private cloud, you have to figure out what's the least you need to keep going, and then on those peak periods, if it's cost effective, you burst to a public provider for a short time, which means now your applications change. If you're going to burst outside of your physical network, the thing that you have to be aware of is your data has to stop. When your application withdraws, it has to write everything out of memory. It's not really necessarily something that applications are good with. I can remember, again, back in my days in IT, a number of applications that lived in memory, and you give them a server with 4 gigs of RAM, and 10 minutes later you install the server, and congratulations, they're using all 4 gig. And you add 4 more because, hey, I'm out of memory on this particular machine, and that application that was installed on a 4 gig machine will expand to fill an 8 gig machine, and now you're out of memory again. And you'll continue to be out of memory because applications aren't necessarily always written to release memory, to release the components that they're using. And because of that, you're going to run into this issue of applications that are not cloud ready. So the next piece, you can take a look at organizational-wide or community cloud-based SaaS, and where you look at how do you build out. So the first thing you could do is you could build your own private cloud. Simple, easy, and allow for your private cloud then to burst into a public cloud or burst into a community cloud for additional resources. And then you could also have your private cloud back itself up into the public cloud. So there's a number of options that you have there, a number of opportunities you have for organizational success. And the last piece is hybrid cloud technology. And you'll notice that through this entire presentation, I have not mentioned the magic word, and that is portability. Portability is a huge play for the future of cloud computing. It is not a play today. It's very difficult to move solutions from one vendor to another. It's very difficult at times to move solutions within a vendor stack, let alone from a Microsoft SQL Server to an Oracle DB, or from an Oracle DB to a IBM DB2, or so on and so forth. It's not easy to move that data back and forth, which is part of a requirement for portability, is the ability to pull the data up and do. In the future, 2-3 years down the road, the cost savings or the cost process for delivering cost savings will focus on the fact that you'll buy cloud services from me, and I will say, okay, I'm going to charge you $17.50 a month for this application that you've given me, and then my job as a broker will be to go find the best price. So maybe I go to Amazon this month because they're giving me a, use our cloud for 60 days for $9 a month, so that I make some back-end profit on the staff I'm going to have to carry. And then I can allow and move that data quickly to Terramark or Lockheed Martin or somebody else who offers that same service at $8 a month the next month. So what I do as a broker is I keep your data portable, your solution portable, but you don't care because in the end it actually operates regardless of where it is. It's then my job as the broker to protect you. And there'll be services that brokers will provide, in particular around the security of data, the security of data in transit, that will be unique to those brokers that organizations will want to leverage and use. And there will be organizations that feel like they can do that on their own, and they'll go directly to the vendors, providing the $8 to $9 cost. So what are the effects? What's going to happen? So large enterprises are going to use hybrid cloud infrastructures for the next few years to leverage both their internal and public cloud. You're going to see that most large organizations will evolve their data centers to become private clouds. I see a huge number of organizations, both commercial and government-based, and even international government and international commercial, moving towards this concept of my data center as a private cloud. You'll begin to see small enterprises actually base their entire business on the cloud. The value proposition of having everything at your fingertips because it's all in the cloud and you can pull it down to your iPad is significant. And then finally, the concept of the portability, that's going to be a huge play in the future. As we go forward, it's going to be a major play that organizations will actually be able to port their solution to a new area or a new, cheaper, lower cost solution. And with that, I will save my standards talk for another opportunity. I do appreciate your being on. If anyone has any questions, I'd be happy to, if you'll type them into the chat manager or something of that nature, I'd be happy to take a swing at answering them.
Scott, I'll just read this one to you.
Sure.
Do you see possible to see it possible to design an enterprise application that targets both on-premise non-cloud deployment and cloud PaaS deployment? If yes, which are the main challenges you foresee?
Oh, that's an awesome question. Well, I mean, you've got a number of so first of all, that is conceivable. In fact, my vote would be that you really design apps for the cloud, even if you do deploy them on-premise. And the reason that you design them for the cloud is there's some capabilities in the cloud that are really going to change how people interact. So if we think about a mobile device, and this actually happened to me yesterday because I was sitting in a meeting where I was not in my office, didn't have my computer near me, and I got an email that was a fairly dense Excel spreadsheet, and I couldn't do anything with it, although the reality was somebody actually needed me to give an answer very quickly based on the data they sent. So the reality is, yes, you'll be able to do that. The modeling and the problems that you're going to run into will be rewriting the entire application to do things differently. So, you know, only present information to users that they can act on. If you need a decision from them, and I'm on my mobile device, you know, send an email back to the original sender of the message saying, by the way, he's only on a mobile device. So intelligence, knowing what device I'm on, that's problem one. And then problem two is when applications hit a server, to actually release the memory and the processes that they're using when they're done. Because that's the cloud ethics, right? That's the value proposition of the cloud is I release the resources I no longer need. Any more questions? Doesn't look like there are any questions. Paul, do you want me to sing for a little bit, or will that scare people and cause nightmares?
I think we're pretty good. Just to post or give you the update, the video will be uploaded on our YouTube channel at Global Iasa, and on the Iasa, and the presentation will be available on the content repository at isaglobal.org. Thank you so much, Scott. That was great. It's nice to have an expert such as yourself come and talk about these things, and hopefully we'll get some further follow-up at a later time. If you do have more questions for Scott, you can email those to web events or education@isahome.org. Either one will be fine, and we will forward those off to Scott. Or you can post those questions up on the YouTube video, and we'll see, or in LinkedIn, and we will try to get you answers. So thanks a lot. And